Hello everyone, my name is Mehdi Golzadeh. I'm a PhD student at the Software Engineering Lab at the University of Mons in Belgium, under supervision of Professor Damien and Dr. Alexandre Decan. I will present the result of our journal first article entitled A Ground Truth Dataset and Classification Model for Detecting Bots in GitHub Issues and Pull Request Comments that we published in Elsevier Journal of Software and Systems in May 2021. Open source software development is a collaborative task, and open source developers work remotely and in geographically distributed teams to achieve their goals. Some open source developers are actively participating in several different projects. They use available software bots or create new ones to reduce their daily workload by delegating routine and repetitive tasks to these bots, which are known as DevBots. DevBots have become an essential part of software development. They are increasingly active in social coding platforms such as GitHub and GitLab. They are used to create pull requests, submit issue requests, commit code, interact with external tools, and communicate with project contributors through comments. We noticed the prevalence of bots in GitHub activities for the first time while we were carrying out an exploratory empirical analysis on the effect of GitHub commands on the acceptance of pull requests. The analysis revealed that the proportion of pull requests involving bot comments was almost twice as high as pull requests without bot comments. This shows that bots seems to play an important role in socio-technical development activities. As such, it's important to have automated methods to identify such bots and distinguish them from real human contributors. We presented our first results in this direction during the BotSE 2020 workshop, and the research published in GSS 2021, on which I report today, can be seen as a significant extension of that work, including a dataset, a classification model, and an open source command line tool for identifying bots in GitHub comments. Identifying bots in GitHub repository comments is not a simple task, since bots use natural language phrases to communicate about their tasks with human contributors. Therefore, we devised a machine learning model to classify whether active accounts in GitHub repositories should be considered a bot or a human, based on some features that can be derived from their comments. As a preliminary step, this required us to create a ground truth dataset that would allow us to train and validate such a classification model. Such a dataset is a first contribution in itself, since we are not aware of any other publicly available dataset that classifies GitHub accounts as humans or bots on the basis of their commenting activity. To create this ground truth dataset, we used the GitHub API to download comments from a large number of GitHub repositories. This resulted in over 10 million comments of more than 873,000 distinct accounts from over 136,000 repositories. We developed a rating application to allow us to manually classify over 5,000 GitHub accounts on the basis of their issue and pull request comments. To achieve high inter-rater agreement, we used the following process. The comments of each account were inspected by at least 2 raters. Difficult cases were inspected by a 3rd rater. Cases with disagreement were discussed by all 4 raters to reach a consensus. This process led to a manually validated ground truth dataset containing 4,473 distinct human accounts and 527 distinct bot accounts. To create a classification model for distinguishing bots from human accounts on the basis of pull requests and issue comments, we relied on the following features. During the rating process, we noticed that bots tend to produce groups of similar comments and tend to use a specific text pattern in their comments. There, the first feature we used was the number of distinct comment patterns. This required us to compute comment similarity. To do so, we combined the well-known Jaccard and Levenstein distance metrics and used them to create cluster of comments based on the dbScan data clustering algorithm. In this figure, we observe that most humans are along the diagonal line, which indicates that the number of patterns is close to the number of comments, and almost all bots are along the horizontal axis. This means that the number of comment patterns for bots remain stable and low regardless of number of comments. As a second related feature, we used the number of comments. Indeed, an account containing 8 comment patterns out of a total of 10 comments is more likely to be a human compared to an account containing 8 comment patterns out of a total of 100 comments, which is more likely to be a bot. As a third feature, we used the number of empty comments for each account. This feature was motivated by the fact that bots tend to produce informative comments, whereas humans often leave pull requests and issue descriptions empty. A fourth distinguishing feature was the distribution inequality of comments in comment patterns. We observed that comments are less evenly distributed in bot comment patterns than in human comment patterns. We used the Gini coefficient to compute this inequality. The figure shows the difference in the distribution of Gini coefficient for bots and human commenters. Based on these 4 features, we created 5 types of classification models, namely random forest, k-nearest neighbors, support vector classifier, simple decision tree, and logistic regression. We used a tenfold grid search cross-validation to compare the performance of these classifiers with varying parameters on our ground truth dataset. 60% of the dataset was used for model training and validation, while the remaining 40% were used to evaluate the performance of the selected model. We achieved a very high F1 score of 0.98. For more details, we refer to paper itself as well as to the replication package that we made available on GitHub. In order to use the bot identification model in practice, we developed an open source command line tool in Python. It's called Bodega and can be installed directly from its GitHub repository. Here is an example of how the tool works in practice. In its simplest form, an address to the GitHub repository you wish to analyze and a personal GitHub API key is required. The tool will download all pull requests and issue comments from the specified repository for the specified period of time, which the default value is last 6 months. Then it computes all features required for the classification model, applies the model on the computed features, and reports the classification result. For further details on the tool, we invite you to visit its GitHub repository. Like any research, the presented work has some known limitations that should be addressed in future work. First, our classification model is not able to identify human accounts that mix their normal human behavior with some automated tool that acts on behalf of the user to carry out some repetitive tasks. We baptized such accounts as mixed account. In our BotSE 21 publication, we propose a new classification model that helps to overcome this problem. The second known limitation is that the classification model only analyzes PR and issue comments. Bots can also be active in Git commits or other activities. the approach we followed for creating the classification model also seems to work well for Git commit messages. We developed and presented a prototype tool called BotSE during the Benevolent 2020 workshop. The tool can be found on this address. Thanks for your time, and I would be happy to answer any question.